Hello, everybody, and welcome to this primer on multiple tranche CMOs. What we're going to do is take a mortgage-backed security, divide it into three pieces, and look at the impact of assumptions about prepayment and default and so on each one of those three pieces. So in order to do that, let's start by taking a look at a basic spreadsheet that sets up an underlying mortgage-backed security and has certain characteristics for each tranche of this security. So let me make this a little bigger so you can see it more easily. And I don't know why that did that. There we go. Okay, so let's say we have a pool of mortgages. It's a fairly small pool of mortgages of about $3 million that carry a coupon rate of 3%, 30-year term, 12 payments per year, a PSA percentage of 100% with, for now, no default. Loss conditional on default of 30%, we'll get to that later. And we're going to divide this into three tranches, which are all $1 million tranches. So we're going to divide this into three pieces. And we're going to assign rates to each one of these tranches, 2% to the first, 2.5% to the second, and then the third tranche gets what's left over. And we're going to see the impact of that in a bit. I mean, you can see right there, when we compute the return to that third tranche, it's about a 3.5% return that we get on that third tranche. So how do we do that? Okay, so let's start with looking at a basic MBS setup. We've looked at a number of these before, but when we're doing tranching, a really easy way to set it up is the way we've set it up before. We just look at all of the underlying pool with a balance. We compute the payment for that balance, the interest rate, the scheduled principal. We have a PSA speed. And again, I don't know why this is formatting to dollars, so I will make that look a little better. We'll just call that a number. There we go. And which will determine an unscheduled principal payment. We'll have a default. We'll have a default cash flow in a bit, and that creates a balance. So let's just review quickly what goes into every one of these. So balance is straightforward. We start with an assumption of $3 million, and then we go to formulas and show you the formulas. Okay. We get a payment which is based on our balance at the beginning of the period, okay, which is in the first period just B1, though we could refer here to cell F3 just as well, and maybe that's a little more consistent. Our interest payment in each period is going to be our balance at the beginning of the period multiplied by the coupon rate, which is over here in B2, and that stays constant. Our scheduled principal at each period is going to be the difference between that total payment and the interest payment that we make. And then our prepayment is going to be based on a PSA speed, and our PSA speed is based on, in this case, an assumption of 100% multiplied by 0.2% times the month we're in until we get to month 30, in which case it just flattens at 6%. And the idea here is sort of the baseline prepayment rate is 6% per year. And from that, we can get an unscheduled principal payment for the month, which again takes that annual prepayment rate. 1 minus the annual rate is the survival rate annually. We take that to the 1/12th power. That's the survival rate monthly, because each month's survival raised to the 12th power, that's what survives annually. And then 1 minus that is what is prepaid. And we're prepaying based on what? Well, we're prepaying based on what our balance was at the beginning of the period, less our scheduled principal. So it is how much do we have left over that we could prepay, and we apply a rate to it. Similarly, we have a default characteristic, which is based on how much do we think the default rate is going to be. Again, that's an assumption. We're converting this default rate into a monthly default rate. We put it annually. We convert it into a monthly rate using the same idea we did by converting the annual prepayment rate into a monthly prepayment rate, and we're multiplying that by what's left over after the initial balance, less scheduled principal, less unscheduled principal. So based on what's left over, we are applying a default rate to that. And our default cash flow is going to be the amount of money that we take in after default happens, because we do get recovery. Now, if we're an investor in a Fannie and Freddie security, it's the same thing as a prepayment because our payment is guaranteed. But if we're Fannie and Freddie, we actually absorb this loss. We get to obtain the mortgage, sell the house, recover something. So 1 minus your loss rate, which again is assumed as your recovery rate, multiplied by the size of the default. That is the cash flow you get from a default. Okay, but your balance is not determined by your cash flow, but is determined by the default at the end of the period. And so your balance is your balance at the beginning of the period, less scheduled principal, less unscheduled principal, less that default amount that is reducing principal. Okay, so that's how we set up our loan schedule. And next period, we start all over again. And our payment is going to be a little lower because we have some prepayment and because we have some default, and this payment scheme takes that into account. So once we have this set up, everything else becomes pretty easy. So now we're going to tranche this into 3 tranches of $1 million. And that first tranche, again, I'm going to assume as a balance of $1 million, second tranche $1 million, the third tranche $1 million. Okay, now how does this work? Well, the first tranche gets all the principal until it is paid off. The second tranche gets the principal that's left over after the first tranche gets paid as principal. And the third tranche gets all the principal that's paid after the first 2 tranches get their principal. So for tranche 1, the principal is going to be pretty straightforward. All we have to do is, to get the principal for tranche 1, is to say, okay, is the principal payment in that period less than the amount that is still due to me? And if it is less than the amount that's still due to me, then I am going to take that principal payment, the whole thing. But if that principal payment in that period is more than is due to me, then I'm just going to take what's due to me. Simple as that. Okay. And my balance is reduced in each period by that principal payment. My interest is going to be that assigned interest rate that I gave it, which in this case is 2%, multiplied, which is in B9, multiplied by my balance at the beginning of the period. My total cash flow is just my principal and interest, and off I go. And I copy and paste this down. Sequential tranche 2, it's a very similar sort of idea. Start with $1 million balance. And what it says is this, is if what I am owed is greater than what's left over from all the principal after the first tranche is paid, then I'm going to take what's left over after the first tranche is paid. But if I'm owed is less than that, I'm just going to take what I am owed. Okay, very similar idea, only now instead of just looking at the first tranche, I'm going to look at, or just look at the total balance. I'm going to look at what's due to me. I'm going to look at what's coming to me after I take into consideration that first tranche. Okay, so it's 0.3, the total principal, less the principal that's paid to the second guy. But again, the idea is when I hit that period when the payment that's owed to me is, when the amount that's owed to me is less than the payment that would happen after the first guy is paid, then I just take what's owed to me. And then third guy is just very simple. It's just, he's in last place, so he just gets what's left over after the first two guys are paid. And simple as that. The interest sets up exactly the same way for tranche 2 as tranche 1. They get paid their assigned interest times their balance. But tranche 3, again, is different because tranche 3 just gets the leftover interest after the first two guys are paid off. Okay, so let's take a look and see how this influences the numbers. And what we see is we go here, we look at sequential tranches. One's balance is getting paid down, getting paid down, getting paid down until it hits 0. And at that point, $4,066 of this $14,929 principal payment gets paid to the first tranche to zero that first guy out. And then the remaining $10,862 goes to the second tranche. And this second tranche's balance starts getting reduced until it gets down to 0. And at that point, the third guy's balance, which was $1 million, of course, starts again going down. Same sort of idea. Okay, so from that, we can get cash flows for everybody. We have a principal and interest cash flow for everyone. And we're just going to sum those together to get total cash flows for number 3, number 2, number 1. And then we're going to pull all that together. So we're going to say, okay, what do these guys pay out? And of course, we assign that in the first period's balance. And again, you can see that we just assign that. And actually, what I'm going to do is I'm going to change that to a formula. I continue to have problems remembering that when I'm doing, oh no, it's correct. Equals minus P3 is the formula. I'm not sure why that, oh, because it's equal, there we go. Yeah, minus P3, minus P3, minus X3. And then there are cash flows down the line. And from that, we come back over here and we can see the return to each tranche. And the first tranche is the IRR of the first tranche's cash flows multiplied by 12 to annualize it. Second tranche, cash flows multiplied by 12 to annualize it. This is not the APR. This is, again, the coupon return. And then the third tranche, the same thing. And when we do all that, when we see no default, what we get is we see that 2% assumption come back to us, which is good. The 2.5% assumption comes back to us, that's good. And tranche 3, being in the riskiest position, gets a higher yield. Okay, now, when we think about why should this be different, it's because the duration of each of these guys is different. The first tranche has the shortest duration, the second tranche the next shortest, and the third tranche the longest. Think about the yield curve. There's a relationship between duration, between term, and the rate that you pay. And so in general, you would expect to see the longer tranches get paid higher returns than the shorter tranches do. Okay. Now, let's see what the impact of default on this. So I'm going to just take, assume a 1% default rate. And when we do that, we see, let's see what happens to the yield. Yeah, now the third guy takes all the losses. And that's what you would expect, right? That's what you would expect because the first two guys are protected by the $1 million position. that the third guy has. The third guy gets paid less. So there is protection for guys 1 and 2 from the third guy. He's in what's called a subordinate position. There's subordination of $1 million. And so when you have a default rate of 1% a year with a loss of 30%, okay, that's a loss of about 30 basis points a year early on. Of course, that's going to get smaller because you have prepayment every year. But what we can do is look at total losses from a number of perspectives. First of all, we could just look at what was all the principal paid under this set of circumstances. So here we have in column O, your total principal. Let's just look at that. Total principal. And I'm going to just sum what's in column O, which is the total principal payments for the entire security. And what we get is, $2 million, but so our losses are going to be, okay, what was our initial balance of that security? It's 3 million and then less. And as you know, I like using negative numbers and adding is about $87,000. If we go look here at sequential tranche 3 and look at what their balance is at the end, you can see they're not fully paid. What are they paid? They're paid $87,000, but again, they get some principal that last period. Let's take a look at that. Where is that principal? So if we take that, let's just put those together. I usually don't go beyond. But I'm at 87,131, and I think that matches with the losses that we just saw. Sorry about this. Yeah, 87,131. Okay, so you can double check it. So there you could see all of the losses are eaten by that third tranche. They don't get their full $1 million in principal back. Another way we could look at their losses is, again, if we go back to a default rate of 0, okay, and that's going to zero out our principals here. Okay, the return was 3.48%. Okay, so loss before default, or excuse me, return before default is equal to 3.48%. And actually, I'm not going to do that. What I'm going to do is I'm going to copy and paste that value in there so it doesn't change. That look a little prettier than it does. And there we go. Okay, return after default is going to be equal to right, this guy once we put the default in, and so that's 0.01. So that's that 295. So what is your return loss? Is going to be equal to 1 minus what you get divided by what you thought you should have gotten. So about 15%. Again, sorry, that's ugly. So I will clean that up. Take a loss of about 15.2%. So that's an overview of how you look at tranched CMOs with sequential tranching, the impact on returns, looking at changes in prepayment, looking at changes in default. Again, you can do a lot of things with this kind of spreadsheet. So I'll put the default back at 0 just for a second here. Okay, and oops, that was a mistake. That should still be 1. Where's my default? Oh, there we are. There we go. We can also play around with, okay, what's the impact of changing prepayment? So if we move this to 200%, what does that do to our return? And what it does is it actually hurts tranche 3 because the first two guys are getting paid faster. Actually, they're getting their money back fast. Oh, so they're getting less. That's right. Because they're getting paid faster, their early on their interest rate payment goes down, right? The amount that's available for interest goes down. But ultimately, this is like the IO strip point. If we do 10, the fact that they get their principal back faster is something that they like, and so their return goes up. So this is the sort of thing that you can play around with to find the impact of payments per year, or excuse me, PSA percent. I'll put this back at 1 where it was before, default, etc., on each of the 3 tranches. And so that's a brief primer on sequential tranching CMO.